In the last video, we did problem 65, and we got the answer, and we did it kind of an intuitive way. But if it was a slightly harder problem, it would have gotten a little more complicated. So I really wanted to show you how you can do it with the binomial theorem as well, or at least with binomial coefficients, and then we can try to see if how they relate to each other, that they're actually the same thing. And I realized that I should do this because I'm looking at the next couple of questions. They all deal with the binomial coefficient. So I figured I might as well do it the binomial way because that's probably what the California standards want you to do. And it's a good way. It's good to be able to do it intuitively and with the binomial coefficients and understand how they're the same thing. So reading the same problem, Teresa and Julia are among 10 students who have applied for a trip to DC. 2 students from the group will be selected at random for the trip. 2 students for the group will be selected at random for the trip. What is the probability that Teresa and Julia will be the 2 students selected? So the way we did it last time, we said, okay, we could pick Julia first, and there's a 1 in 10 chance, and then we would pick Teresa, and that's a 1 in 9 chance. Or we could go the other way around. So it would be 2 times, it would be 2 times 1 over 10 times 1 over 9, right? 2 because there's 2 different ways to pick the people. And then for each of those ways, there's a 1 in 10 chance of picking the first person, and then a 1 in 9 for the second. That was the intuitive way we did that in the last video. The way you would do it with the binomial coefficient, you would say, okay, I have 10 items, 10 students in this case, and I'm going to choose 2 of them. And people will often read this as 10 choose 2. And it's useful to memorize to some degree what this means. This means 10 factorial over 2 factorial times 10 minus 2 factorial. And so that is equal to, and I'll give you a second what the intuition is, that's equal to 10 factorial over 2 factorial times 8 factorial. And at first you might say, oh my god, 10 factorial is a huge number, right? It's going to take me forever to multiply that out. But until you realize that you're dividing it by 8 factorial. So 10 factorial that's the same thing as 10 times 9 times 8 times 7. And you keep going. But 8 factorial is 8 times 7 times 6, so forth and so on. So the 8 factorial, if you divide it into 10 factorial, that's going to cancel out with that. And you're just left with 10 times 9, right? So if you had to say how many different ways can you pick 2 people out of 10, you then get 10 times 9, which is 90, divided by 2 factorial, which is 2 times 1. So you say there's 45 different ways to pick 2 people. So the chances that I pick one of those ways, right, pick Julia and Teresa, is 1 out of 45. Right? There's 45 combinations of picking 2 people out of 10. So the chances of picking any one of those combinations is 1 out of 45. So you get to the same answer. And just to get the intuition, this thing boils down to, we just saw, it boils down to 10 times 9 over 2 factorial. And if you just want the intuition, there's 10 ways to pick the first person. There's 9 ways to pick the second person. And then there's 2 ways, or 2 factorial ways, that you could have picked one person and then another person. So it's the same intuition as this. But if you just wanted to kind of plug and chug and get the answer, you say, oh, 10 choose 2. That gives me the answer. I have 10 things, I need to choose 2. That gives me 45 different combinations, and I want only one of them. So that's 1 out of 45. Next question. Let me see. Let me scroll up. All right. And this is, when I saw this, I was like, oh, they definitely want us to deal with binomial coefficients. And I'll show you 2 ways how to do this problem, too. So this one says 3y minus 1 to the 4th power. And you could multiply it out just using regular algebraic multiplication, polynomial multiplication. It will take you some time, and you might make a careless mistake. I'm guessing they want us to use the binomial theorem. And the binomial expansion of this, I'll use that combinatorics or that binomial coefficient notation. And I think you'll get the pattern. And I've done several videos on this where I explain deeper why it works and all of that. But it equals 4 choose 0 times the first term to the 4th power, 3y to the 4th, times the second term to the 0th power. So you don't only include it. That's times 1. Anything to the 0th power is 1. Fine. Plus 4 choose 1 times the first term, so that's 3y, to the 3rd power, I'm just decrementing it on each term, times the second term to the 1st power. So times -1 to the first power. And in general, if you want to know what should this exponent be, it's going to be whatever is here. So this 1 is the same as that. So here we had a 0, and so negative 1 to the 0, I didn't even take the trouble to write that down. So let me just keep going. I'll switch color. So the next term, you could probably pause it and guess it. It's going to be 4 choose 2. And I know you're wondering, well, what is this 4 choose 1 and 4 choose 2? Well, we saw it in the last problem, but I'll calculate them in a second. That's going to be 3y squared times negative 1 squared. And we have two more terms, plus 4 choose 3 times 3y to the 1 time. And just so you know, I mean, the exponents of these two should always add up to 4. So you have 4 and 0, you have 3 and 1, 2 and 2. So in this case, you have times negative 1 to the third, and this 3 is that 3, plus 4 choose 4 times negative 1 to the fourth power. Negative 1 to the fourth power. So what do each of these binomial coefficients equal? 4 choose 0. 4 choose 0. That is equal to, I'll do it in yellow, that's equal to 4 factorial over 0 factorial, which you may or may not know is defined to be 1, over 0 factorial divided by 4 minus 0 factorial. And so that just turns into 1, right? 4 minus 0 is 4. So you get 4 factorial over 4 factorial. So this is equal to 1. So let me write it out. So 3y to the fourth. 3 to the fourth power is what? It's 81, right? 3 to the third is 27, right? So we get 81 y to the fourth. All right, next term. Well, the first thing that you see is you have this negative 1 to the first power. This negative 1 is just going to keep flipping the sign. So negative 1 to the first power, that's just going to make this whole term negative, and then we can ignore it from there. So we're going to get a negative there because of this negative 1 to the first power. And what's 4 choose 1? So that's 4 factorial over 1 factorial, which is also 1, divided by 4 minus 1 factorial. 4 minus 1 factorial. So that's 4 factorial over 3 factorial, right? So that's 4 times 3 times 2 times 1 divided by 3 times 2 times 1. So that just equals 4, right? Try it out if you don't believe me. 4 times 3 times 2 times 1 divided by 3 times 2 times 1, you just left with a 4. So you get 4. This coefficient becomes 4, but it's 4 times 3 to the third power, right? So maybe I'll just write it. So the binomial coefficient is 4 times 27 y to the third, and we already took care of the negative 1. Negative 1 to the first power is negative 1, and that's why I put the negative there. So the next term we have a negative 1 to the second power, so it's going to be a positive, right? This is just going to turn to a 1. That turns into a 1. So it's plus, what's 4 choose 2? 4 choose 2 is, I'm already running out of space. I'll write it up here. It's 4 factorial over 2 factorial times 4 minus 2 factorial. 4 minus 2 factorial, that's also 2 factorial, right? So it's equal to 4 times 3 times 2 times 1 divided by 2 factorial is 2, and 2 factorial is 2. Let's say this 2 cancels out with that 2. This 2 cancels, let's see, if you cancel out that 2, that becomes a 2. So you get 2 times 3 just becomes a 6. So that third term just becomes a 6. 4 choose 2 is 6. I know this is messy. So you have a plus 6 times 3y squared. So 9 times 9y squared. And we could keep going. And actually, the binomial coefficients, the next one's going to be a minus. The next one's going to be a 4, and it's negative 1 to the third, so it's going to be a minus 4 times 3y to the 1. I mean, we could keep going pretty. Actually, let's just keep going. So the next term, 4 choose 3. I'll leave that you calculate it, but I already know that since we're kind of past the middle point, the binomial coefficient is going to be the same as 4 choose 1. So it's going to be a 4, and we have a minus 1 to the third, so this is minus 1. So it's minus 4 times 3y to the 1. So times 3y. And then we have the last term, 4 choose 4. You could calculate it using this formula, but that turns out to be 1 as well. Plus, so 1 times negative 1 to the 4th, so that's just plus 1. And let's see what this is equal to. Let's see if we could simplify it. This is equal to 81 y to the 4th minus, let's see, 4 times 20 is 80. 4 times 7 is 28, so it would be 108. 108 y to the 3rd 6 times 9 is 54, so plus 54y squared minus 12y plus 1. And if we look at the choices, only choice A, yeah, right, A is the right answer. And actually, we could have figured out it was choice A just by going one term deep, because that's where all of the problems, all of the choices became different, so we could have saved a lot of work. Another option, instead of evaluating each of the binomial coefficients, another option would have been used to do a Pascal's triangle, where you say, okay, if I have, A plus B to the first power, the coefficients are 1 and 1, right? 1a plus 1b. If I take it to the second power, a plus b squared, the coefficients become, and this is where they'll pass, 1 plus 1 is 2, and you bring down a 1 both places, right? And that makes sense because a plus b squared is 1a squared plus 2ab plus 1b squared. And then we could have kept going. This would have been to the third power. You get a 1, a 3, a 3, and a 1. And then the fourth power is what this problem was about. So you get a 1, you get a 4, 3 plus 3 is 6, 3 plus 1 is 4, and you get a 1. So you said these would be the coefficients, and in this case, we were doing 3y minus 1 to the fourth power. So we would have said 1 times, so we would have, if we had just drawn this out really fast, we would have said, well, this becomes 1 times 3y to the fourth plus 4 times 3y to the third. I just keep decrementing the 3y times negative 1 to the 1 plus 6 times 3y squared. This 6 is this one. I'm getting a little misaligned. 3y squared times negative 1 squared. So every time I increment the power on negative 1 and I decrement the power on 3y, and then plus 4, now I'm at this one, plus 4 times 3y, negative 1 to the third, and then finally plus 1 times 3y to the 0 is just 1, times 1 to the fourth power, negative 1 to the fourth power. And I would have evaluated it. And that might have been a slightly faster way of doing it. But I wanted to do this a couple of different ways because I think the binomial theorem and binomial expansions is something that people forget, and it's important to kind of have the neurons make a lot of cross connections so that you don't forget it when you're 30 years old. Anyway, this was the least number of problems I've done in a video, but I think it was worth it. I'll see you in the next video.